I'll do a MATLAB code, okay, where the wiggles will form. I will take the image and I'll share with you how you can, then there you can see how it looks like, and you can, and when we will move to the module discretization and solution procedure, that time you can you also write the same code, and you can also take that field. If you are doing the from the volume and stability analysis, you can come to know what DT you should choose to get the stable solution. Otherwise, you will
Sir,
get the.
what is the discretization and solution procedure?
See, discretization means, have you ever did any CFD analysis, whether it is for the like fun purpose or anything? I won't expect you know CFD simulation you did. Have you ever done
No,
anything?
no,
Okay.
sir. No.
Have you ever heard about meshing?
What, sir?
Meshing.
Meshing?
Ah,
Yes, sir. Yes.
yeah, that meshing is nothing but the discretization. Let me explain what is this. You have there is a circle. Okay, there is a circle. You have to get the area. Let us consider you do not know the formula pi r square. Okay, let's suppose you do not know this formula. What you can do, you can make it a small, and you know the formula for the triangle. You can make a small triangle,
Oh,
right? Now
yes.
you can calculate the area of the each triangle. Okay,
Yes.
then you can sum, then you can get the area of the, when you will sum, you can get the area of the entire circle,
Circle. Yes, sir.
right? So
Yes, yes.
these small triangle are nothing but the discretization. You are just discretizing your domain.
Yes.
Okay, let us consider in
Okay.
CFD what is there. In CFD, there is a, let us consider there is a pipe in which water is entering at inlet, and there, this is my outlet. So when you are solving, at the end, what CFD is doing? CFD is solving the Navier-Stokes equation. Okay, CFD is solving the Navier-Stokes equation to get the your flow parameters like pressure, temperature, velocity, all those quantities that you are looking for, right?
Yes, sir.
So CFD won't directly solve this one. What you are doing before the simulation, you will do the some grid generation, like meshing you will be doing. Like your
Yes.
entire domain, now you are dividing into small. You are breaking this entire type into small. Either if it is a structure, then it will be hexa. If it is unstructured, then it will be tetra or poly. Kind of small domain. You are breaking it to small mesh, right?
Yes.
So these are called as a discretization. These processes are called as discretization. When you are making this small, up to how much small you can go, okay? It is not like you can go up to like very fine. You cannot go, na?
Yes.
Or even you cannot make it even very big. Okay. So what would be the optimum? What would be the optimum size? That comes from the stability analysis, and that will come in the stability analysis. Okay, and the solution procedure.
Okay.
Okay,
Okay,
like
sir.
when you will do the stability analysis, there you can understand what should be your dx size and what should be your dt in order to get the stable solution. And this process, making this, converting this entire big domain into small domain, is called as a discretization. You got the point? And the solution procedure is nothing but the procedure that you will be maintaining to solve. Like at the end, you are solving the Navier-Stokes equation only. At every mesh cell, at the every cell center, you will be solving Navier-Stokes equation to calculate the flow parameters. So what are the solution procedure you will follow? Okay, those things I will be covering in this lecture. Got my point?
Okay, sir.
If even if you have very small doubt, you also ask me. Okay, don't hesitate. Make it very much interactive.
Yes.
If anywhere you feel that I may feel okay, I am explaining well. For your point of view, I may be very fast. So there you just stop me. Okay, You just stop
Okay,
me so
sir.
that you tell what is this.
Okay, sir.
Okay. So while as I already told you, there is a pipe flow is entering and there is exit. There is a chance that we are not chance, definitely we are solving the Navier-Stokes equation. Okay. So
Yes,
in
sir.
Navier-Stokes equation we are solving, definitely it is taking there would be some background code would be written to solve. Okay, maybe they
Yes.
have written in C++ or maybe C programming, any OOPS oriented language, objective using OOPS concept they might have written. Okay, procedural language maybe they have used to C. Okay, whatever they have used, any commercial software. But in our course, I'll be focusing on the MATLAB. Okay, so as
Okay.
we by the time you are ending this entire module, you will be developing skills uh, where you can explain what is variable, what is array, what is matrices, how you can define the loop, how you can make the conditional loops, how you can make the function to solve the Navier-Stokes equation, how you can make the structure of the MATLAB code, and the plots that you want, how to do the plot, and how you can do the file parsing. Okay,
Okay, sir.
so these are the concepts you will be learning. So how you will
Okay.
learn these courses? You will be I will give you two projects to do, where I will also help you. Okay, those two
Okay, sir.
projects while by the as soon as you are covering these two projects, as soon as you are successfully doing these two projects, you will be learning entire this process, and you would be at a good stage of covering this knowledge application point of view. Okay, then
Okay,
you
sir.
won't
Okay,
use
sir.
the commercial software like ANSYS as a black box. At that time you can understand, okay, what is CFD. You won't be using ANSYS as a black box, otherwise you will be as a blind you will be putting the maze, dt, this scheme, that scheme, but if your permutation combination is good, you will be getting good result, otherwise you won't. If you are going through this course, you can understand, okay, these are the scheme, these are the grid size, these are the time step, then I have to do this procedure, follow this methodology, then definitely you can trust in your result.
So that means we will do all these things in MATLAB software and ANSYS software, right?
Yes, whatever we do, we'll do in the MATLAB software. So and in MATLAB, you are by yourself, you are doing the code, so that you can trust. You can say that yes, I know the how behind the software how it is working. Okay, because MATLAB never share their intellectual property. Okay, you have to learn by make your hand dirty with the code.
Okay, sir.
So this is the whole concept behind this course.
Sir,
Uh,
I am currently the behind the schedule in studying fluid mechanics right now because there was a function few days ago, so
mhm.
that's why. So I think 22 chapters are remaining
Okay, okay.
to
See,
study.
by the time I am teaching this course, you won't require the much fluid dynamics knowledge, and whatever the fluid dynamics knowledge would be required, I will be covering from the very